Welcome. Continuing on with our work on similar triangles, you probably noticed when we started working with similar triangles that we were required to set up a proportion in order to solve for side length. What I wanted to do today is a review on polynomial multiplication. You guys did study this in algebra in the past. It's going to become really prevalent the more we work with similar triangles. So the thing is, when we set up a proportion, what we do to solve is we cross multiply, right? So 3 times 5 is what we would do first in the problem that I wrote down here in this case. 3 times 5, of course, is 15. That's easy. The problem occurs when we get something like this. We have x plus 1, which is a binomial, times x minus 2, which is another binomial. And in my experience, it's been people sometimes forget how to multiply that. I see a lot of common mistakes, so I just wanted to practice and review the skill with you before it becomes an issue for you. So to do a multiplication like this one here, we have two different options for you to use. The first one is more algebraic. Okay, this is called double distribution. A lot of times you'll see it in schools or in textbooks referred to as FOIL. They like to call it FOIL. Okay, FOIL stands for first, outside, inside, last. Okay, that's just telling you the order and how to multiply. When you do double distribution, it should almost look like you're drawing a double rainbow on your paper, and I'll show you what that means. So first we have the F, right? The F in FOIL stands for first. So we're going to take the first two terms in each of the binomials and multiply them together. Well, x times x, that's x squared. Okay, pretty simple. Next, we have O, stands for outside. So I'm going to take the two terms that are on the outside of the parentheses, and I'm going to multiply them together. Now remember, signs do matter. This is a negative 2 times x, which gets us a negative 2x. And you can already see like this rainbow forming above here. Okay, that's what we want. Now we're going to make this a double rainbow. Now we have to multiply I inside. So the two terms that are inside the two parentheses, we're going to multiply together. That's 3 times x, which gets us a positive 3x. And now the L stands for last, right? Last, take our two last terms. That's 3 times negative 2, and we get a negative 6. Now, if they don't combine, you write them in a line. However, you might notice here that we do have like terms, and this typically does happen with the two middle terms, the x terms. They will combine and simplify a little nicer. So here in this case, negative 2x plus 3x is actually positive 1x. You could have the 1 in there. X squared doesn't simplify any further. Plus 1x minus 6, and that's our polynomial that we get as a product. From there, you'll be able to solve if this was a proportion you were doing for a similar triangle. Okay, that's method 1. That's our double distribution, double rainbow, or FOIL method, however you want to call it. Our second method that we could do is what I like to call the grid method or a box method. Okay, so here we have the same problem that we just did on the last page. So our answer should be the same if we did this correctly. What you have to do first when you're doing the box method is you want to draw a 2 by 2 grid. The reason why we want a 2 by 2 grid is because we're multiplying a binomial, which has 2 terms, times another binomial that has 2 terms. So 2 by 2, one to represent each term. So what you're going to do is you're going to put one binomial at the top of the grid. Doesn't matter which one, but you do want to take the signs with it. For what I mean by that is this positive 3 should stay consistent through the problem. The other binomial can go down along the column. So we have x minus 2, right? You want to make sure that negative sign stays through. Now you're going to multiply the rows and the columns of the grid to complete the interior of each. And I'll show you what that means. If you take a look at this first box, okay, this first box is an x by x box. All right, x times x, we get x squared. Let's keep working our way around. I'll keep it color coordinated so it's a little easier for you to see. Now I'm looking at the top right box. Well, its dimensions are x by 3. 3 times x gets us 3x. Let's take a look at what's next. Let's go back to the bottom left here. So now we have x and negative 2. We multiply those two together. It's negative 2x. And our last box is 3 and negative 2, this box right in here. Remember, we're always multiplying in this box. Some people get tempted to add, but here it's negative 2 times 3 is negative 6. Now, I notice a lot of people do like this method, but you have to remember once you take it from this point, you have to take it outside of the grid. So now I'm going to take each of these 4 terms and I'm going to write them in a line. X squared plus 3x minus 2x minus 6. Notice that I'm writing them in descending order from biggest power to smallest power, and that's how you should always write a polynomial. Now you want to combine like terms wherever you can. Here in the middle, yet again, it is pretty common, as I said before. X squared plus 1x, you could just write x if you'd like, minus 6 is our final polynomial. Let's just check to make sure those answers match. And they do, so we're in good shape. So these methods are 2 you want to consider tomorrow when we start looking at solving similar triangles, where we're required to cross multiply, but it involves algebraic expressions inside too. So thank you for watching. I hope this helped. Please refer back to it at any time when you're doing your homework or in your lesson tomorrow. Thanks for watching. Have a good